Now everybody's awake. We can start the afternoon with some nice Ruby motion. So I'll give the word to Laurent.
Hi. So can you hear me? Yeah, perfect. Awesome. So let me put this here. Welcome to Belgium. And the weather is awesome, right? Okay, so I'm going to give a presentation about Ruby motion. Does anyone know what Ruby motion is here? Do you? Some of you. Okay, like half of the room. Perfect. So Ruby motion. First, let me introduce myself. I'm a long-time Ruby enthusiast, so I've been using Ruby for about 10 years. So I really love Ruby. Ruby is my favorite high-level programming language. I'm more of a C programming guy actually. So, but I like to use Ruby for application development, and I love all programming languages. So I'm even working on my own programming language. I really like that. In the past, I was working for Apple for 7 years in Cupertino, where I work on iLife, OS X, and more recently, the core foundations of iOS. One of my projects at Apple was MacRuby, and MacRuby is an implementation of Ruby for Mac technology. So MacRuby lets you use Ruby to write Mac applications, and it's actually interesting because MacRuby is based on the same foundations as Objective-C. So it is different from the old project called Ruby Cocoa, on which I also work on and maintain, which is more like a middleware framework between two existing runtime. And MacRuby was supposed to replace Ruby Cocoa. And when I was at Apple, last year, I realized that people would be really interested in using MacRuby for iOS development. But it requires some work, and Apple was not very interested in letting me do that. So I quit the company to do a startup here in Belgium. And the startup is called HipByte, and the product is called Ruby Motion. So it's a port of MacRuby. That ad is very annoying. It's a port of MacRuby for iOS. Perfect. Let's go ahead. So Ruby Motion. Nice. That's a nice animation, right? Now that I'm not an Apple employee, I can do all this crazy stuff in the presentations. So it lets you use Ruby as a programming language to do iOS development. I'm going to remove that because it's really annoying. So you can really use Ruby for to write iPhone, iPad, or iPod Touch applications, and it's a product. So it's more or less open source, but you need to purchase a license to use it. Why would you want to do iOS development? I mean, if you're already a Ruby programmer, you probably do web development. Ruby is very popular in the web space, and Ruby is not so much used for anything else. And we want you to use Ruby to do iOS development. And the reason is that it's actually a very important market. So as far as we know from Apple, there is 365 million iOS devices in the market right now that have been sold since the first iPhone. And there should be around 400 million iTunes accounts linked to a credit card. So this is potential customers that can purchase applications. So this is a very big market, and therefore there is a lot of demand for iOS consulting, as you may know. And it's also possible to sell applications on the store. This is our first success story. So I'm very proud of that. Everclip is an iPhone application written in Ruby Motion, 100%. It's the first commercial application, and I heard they make quite a bit of money right now. And it makes use of a lot of third-party Ruby Motion libraries that I will talk about in this presentation. And I heard that they even won the Evernote Dev Cup. So it's a Evernote application. Anyways, just wanted to show you that. So what is Ruby Motion exactly? Ruby Motion is an implementation of Ruby, but for iOS. So it is not using the regular Ruby implementation that you know. It is a totally different implementation. It is also a statically compiled version of Ruby. So RubyMotion implements a dialect of Ruby suitable for statically compilation. So I will also explain that. RubyMotion is all based on the terminal. So you drive, the entire toolchain is driven from the command line. So you don't need to use any IDE or user interface. You just use straight the terminal. There is no editor for RubyMotion, so you get to use your favorite editor. So we don't want to force you to use a specific editor. And the community is growing around RubyMotion, and there are lots of very nice libraries. And I would like to show that to you. So first, let's check about the runtime. The runtime of RubyMotion is it's a bit unique compared to the other mobile platforms. In RubyMotion, we re-implemented Ruby at the same level where Objective-C is also implemented. So in RubyMotion and Objective-C are using the same framework, the same runtime, sorry. So which means that in Objective-C, when you define a class, it's going to register a specific structure inside what they call the Objective-C runtime, which is a very thin runtime running on top of the C language. And in RubyMotion, we use the exact same representation for classes, objects, and methods than Objective-C, which means that in RubyMotion, when you define a class, and we define a method inside that class, and you create an instance of that class, and you pass this instance to Objective-C to an iOS API. iOS is implemented in Objective-C, so you pass just a pointer to that object, and Objective-C will call your method back. And there won't need any performance regressions. They won't need any conversion needed between objects. So it's actually a pure native platform. So it's actually very, very, very nice. It is different from other platforms where you have a middleware, like a framework, that sits between two existing VMs or runtimes. That can get very complicated to maintain because you need to keep track of all the object models running at the same time. You need to keep track of two different garbage collection models. So it can be very hard. In RubyMotion, there is only one runtime, so it's actually very, very cool for development. And at the same time, in RubyMotion, we use the Foundation framework. Foundation is it's a built-in framework in iOS that provides built-in classes. For instance, there is a class for string, a class for array, and a class for a dictionary, which is a hash. And in RubyMotion, we use these classes, this code, to re-implement the Ruby equivalents. So in RubyMotion, a string is actually an NS-string, which is the Objective-C version of the string. So which means that you can create built-in types in RubyMotion and pass them to iOS. And vice versa, you can get iOS types, and they will behave like Ruby types, and they won't need any conversion needed. So this is actually a very, very important point because when I was at Apple, we did a bit of experimentation around bridges, and we found out that most of the types that cross languages are built-in types. So by using this new architecture, we can make sure that RubyMotion can be as fast as Objective-C. But you may know, if RubyMotion is as fast as Objective-C, why should I use Ruby? I could just use Objective-C, right, if I know Objective-C. Well, Objective-C is a fine language, but it was a fine language 30 years ago, actually. 30 years ago, it was awesome. I mean, that was that or C++, right? And now Objective-C didn't really age well. But just take an example. This is a very basic hello world application in Ruby. So you can probably read that code, right? Very simple. And the same code would be that in Objective-C. So it's about 3 times bigger. And this code does exactly the same. And we define a class with a constructor. And in this constructor, we get an argument that we set as a property to that class. And then there is a say method that just prints the variable. The same thing that this code did. But it's 3 times bigger. Why? Because in Objective-C, you have a lot of boilerplate code when you create classes and methods. And it's based on the C language, so you get to use types. It's kind of a problem. And you also need to write code to different files, like header files and implementation files. You don't need to do that, but if you want to follow good principles of programming, and you need to split your interfaces between two separate files, and which is kind of great. But you have 3 times the code as in Ruby. 3 times the code means more opportunity to introduce bugs, harder to maintain the code at the end, and you get less time to play video games. Or Skyrim, if you like Skyrim. And so we have RubyMotion has been around for a few months now, and some of our users, they rewrote their existing Objective-C apps in Ruby. And generally, what we hear from them is that they get rid of 60% of the code. 60, 70, so more. You get to use only, at the very end, you only have 30% of the original code. The same logic, API call per API call. Everything else, you can just drop it, which is much, much better for maintenance. Okay, so that's an example of OpenGL in RubyMotion. So I have no idea what this code does, by the way. It was contributed by someone. But what I want to show you here is that you can use, so RubyMotion is based on the Objective-C runtime, so you get to use all the Objective-C APIs for free. But in iOS, Objective-C is not the only language for APIs. And OpenGL is the perfect example. OpenGL is a pure C framework. So all the APIs are in C. So you get functions, structures, enumerations, constants, all the crazy sharp defined macros. So it's really a pure C framework. But you can use this framework in RubyMotion because our static compiler is aware of all the C stuff. For example, here, all the GL stuff you see are actually calls to C functions in OpenGL. And the static compiler will actually replace these method calls by a write call to the C function. So it's almost as fast as coding C code. The uppercase GL underscore stuff constants are actually enumerations, I think, or I don't know, probably stuff in the headers. But you can do that. You can access these as if they were Ruby constants, and again, the compiler will replace them. So you can really use any API of iOS from RubyMotion. So it's pretty neat. And this code looks exactly the same as in C, by the way, because this is C code. So there is no more. You can't really improve it. Like it's just a function call. And it's actually funny because the first 2 lines, the guy forgot to remove the semicolons, which is mandatory in C. So you pretty much copy-paste the code in the Ruby file. Anyways. Now let's talk about the compiler. So the compiler is based on LLVM, and this is the logo of LLVM, which is the most awesome logo ever. Really, right? Anyway, LLVM. So it is very different from other Rubies in the sense that normally in C Ruby, the default implementation of Ruby, the Ruby code is actually interpreted at runtime. So it's actually precompiled into bytecode and then interpreted into a specialized virtual machine. In RubyMotion, we don't want code to be interpreted on the device. We don't want any interpretation, even bytecode. So in RubyMotion, we transform the Ruby source code at build time into machine code, and then there is no more interpretation anymore. So we want that to more or less conform to the Apple guidelines. So the Apple guidelines are pretty vague in this regard. They say that you cannot really interpret code. You can if you don't download it, but to be sure, we just generate straight machine code, and then there is no more interpretation, which means that there are things in RubyMotion that don't work. For instance, you cannot use evil with a string in RubyMotion. That's forbidden, because you cannot interpret code. And also, the require method of Ruby is not available in RubyMotion, because we don't require files in RubyMotion. We provide all the files at build time in your project directory, and then we just, boom, generate an executable. So how does it work, actually? I'm going to explain the compilation process. So first, we start with the Ruby text file. So it's basically text. Here we define a subview of UI view with a specialized drawback method, a super call, and blah, blah, blah. That's basic Ruby code. And the compiler will parse this into what we call an AST, a syntax tree, which is basically a tree of tokens. So you can see this as an array of arrays of arrays of arrays. And each part of the array is actually part of the language. So using this syntax tree, the compiler will then generate what we call the LLVM IR. So LLVM, if you don't really know much about it, you can see LLVM as two separate things: a set of modules to write compilers, and then a language for this compiler. And the language is called the IR, also called the intermediate representation. So it's more or less like an assembly language, but like an abstracted assembly language. So here we generate the proper assembly instructions for all the AST of the program. And at that step, after that we have the AST, after that we have the LLVM language, we can perform a lot of optimizations of it, which is where things are going to be interesting. We can, for instance, remove dead code. We can inline specific method calls. We can inline instance variable, get and set, constants lookups, these kind of things. We also have an optimization for, which is called the tail call elimination. So if you have a method that ends with a recursive call, we will replace this with a jump to the beginning of the method. So you can do some sort of functional programming in Ruby. I know that it's not something the Ruby author Matt likes, but I really like it. So we have the IR, and then based on that, we can generate assembly for assembly code for the architectures, and we support the Intel 32-bit for the simulator, and then all the ARM variants for previous iPhones, latest iPhones, and the new iPhone 5. So we generate assembly, and then from that, we generate straight machine code. And this is the stuff you can't really show, right? So I just picked this picture on Google Image, but that's machine code. So this is an application called Mustachio, which I wrote with a friend, Hello Duran, which is one of my heroes. I always say that. And so this application adds a mustache. It does face detection. You take a picture, it does face detection, and then it adds a mustache. So it uses core image. It's very small, actually. It's only 200 lines. And you can see the source code on GitHub if you type Mustachio. It was in the App Store. It's not in the App Store anymore. Not because Apple removed it, because it's written in Ruby. They removed it because I forgot to renew the account, developer account. And I just didn't know that if you don't renew the account, they delete your apps. But what I wanted to show here is I'm not sure if you can see that. The size of the application on the left part is 0.9 megabyte. So the complete application, which is more or less hello world, it's only 200 lines. It's only 0.9 megabyte. It's actually awesome because if you can get because Ruby Motion ships with a very thin runtime. The runtime is about 500K. Then we add a bit of more static code up to the end. But this application only weighs less than 1 megabyte. So in other platforms, you can have 10 megabytes for Hello World, for instance, which can be an issue because I think the 3G limit is 12 megabytes or 17 megabytes, something like that. I don't know, but 15? Okay. So you need to be careful sometimes so that your application is not big enough that users won't be able to download it. So here we are, and we're actually working on reducing the compiler code to 300K less, but maybe next year. So the compiler generates very small code. So let's talk about the toolchain. The entire toolchain is written on the command line. So you use the terminal for everything. So use the terminal to create a project. And the project is basically a directory of files. And in this directory, you have a reg file. And the reg file contains the entire project configuration. And by default, the reg file is only 3 lines, I think. So everything else has default values. And so it means that if you want to change something, there is only one file to edit. So you need to use Xcode or a specific complicated file in XML or whatever. This is just plain Ruby inside the reg file. And the reg file by default has a set of tasks. And the most important tasks are the task that sends the application to the simulator, the task that sends the application on your device, which is connected to the computer. And since 1.24, which was released two weeks ago, we can now launch the application right away in the debugger. So it's awesome. And finally, there is a task to generate an IPA file suitable for distribution. So you can send it to the App Store, to a test flight, whatever. You can submit your application to people. Yeah, let's talk a bit about the debugging. The debugging code was added 2 weeks ago, and it's actually interesting because the RubyMotion compiler implements Dwarf. Dwarf is actually a standard for debugging information. It is mostly used in C-based languages. And as far as I know, this is the first time Dwarf is actually implemented in a high-level dynamic language. So the compiler emits some sort of metadata. At the same time, it generates code for Ruby. And the metadata contains, for instance, this specific method is defined at this offset in the executable. And we know that it's also this file and this line. So it's actually very important because you can attach a debugger to it, and then you can expect, for instance, the backtrace. Or if the application crashes, you will get a crash report. And the crash report contains the basic stack trace where the crash occurred. So it's a linear stack trace following the stack pointer, but you only have addresses. And then you know that, for instance, these entries in the stack frame are from Objective-C. But the Ruby ones will actually be annotated, so you know exactly where this is in my code. This is very, very important for debugging and also for interpreting stack traces. And since 1.24, you can attach any debugger. So we use GDB because it's probably the best debugger right now. But you can attach any debugger to a RubyMotion app, and you can set breakpoints, inspect local variables. And then we have GDB macros that let you inspect instance variables, constants, kind of things. So it's actually very cool. And well, here is a debugging session. So the first part we break in the timer controller.rb file at line 32. Then we continue the execution. Then if we ask for the backtrace, you can see that the first entry is actually our method. And this is like, you may not feel this is magical, but this is really, really great. And for testing, we have RubyMotion ships with an RSpec-like framework. It's called Beacon. It's like RSpec without the huge code, so it's very small to maintain. And it's also a fork of Beacon in the sense that it integrates with the UIKit run loop, so that the test will actually be executed once the application starts. And it also provides functional testing. So you can run functional tests with this part. And you can do also test-driven development if you like. And the functional layer is based on UI automation, which is the framework Apple wants you to use to do testing. It's basically a framework that provides methods to set events to your application, like for instance, tap this very specific button, or scroll down, or rotate the device. But in Objective-C, you generally use UI automation through JavaScript. They provide a bridge, and you need to use JavaScript to test your applications. And you also need to use instruments, which is a very complex application. And here, you do everything in Ruby. So this is much better. And this is an example of a spec. So we have primitives like the view primitive. You pass a string, and it will actually try to locate the specific view inside the window based on the accessibility level. Then you can, for instance, the second hit close, it wait. You can see that we tap buttons. So you can actually manipulate the entire application, and you can even create scenarios if you like. Okay, so this is Xcode, which is a default IDE that Apple provides for iOS development. And in RubyMotion, we don't support Xcode at all. No Xcode, because we don't think it's a good editor for Ruby, or even for other languages. It's very, very bad. It's such a shame. Yeah, in Objective-C it's more or less okay, but in Ruby it's like a disaster. I mean, even TextEdit is better. So we don't really use Xcode, and also we don't support the features of Xcode that people tend to like. Like for instance, in Xcode you can use what they call interface builder, which is like a view inside Xcode. It used to be a separate application. Now it's integrated. And IB lets you build your UI with your mouse, so you can drag and drop windows and views and whatever. And you can set up outlets and actions. This is awesome for very small applications. Once you get a big application, it starts to be complicated, especially if you work with a team, because the NIP file is actually a binary file sitting inside the project. So it's very hard to know what's happening. And it's very easy to break stuff. If you don't write enough tests, you can easily remove an outlet, for instance. If you get to use all the magic that IB provides, like bindings or KVC, KVO, then just one click somewhere, you can break an entire application. And I know that because I worked with IB for a very, very long time at Apple. It's very, it can be an issue. So in RubyMotion, the thing is that Ruby is a great language for DSLs. In Ruby, you can create abstractions very easily. You can do that in Objective-C because it's a C-based language. In Ruby, it's very easy to define languages inside the language. And Rails is a perfect example. In Rails, I don't know much about Rails, but I know there are probably 2 or 3 small DSLs inside the framework. And there is no reason why we couldn't have a nice DSL to define views in RubyMotion. So why would you want to use IB and the mouse if you can build the entire view using very nice DSL? So this is where the approach is going. And there are actually 3 or 4 libraries right now that aim at implementing a UI DSL for RubyMotion. So I think it's a much better way than using code to represent the UI than using a mouse. Yeah, that wouldn't be a screenshot of Xcode without the crash error. And so by default, RubyMotion doesn't support editor, but there are a few editors that have support for RubyMotion. So of course, you guys should use Vim because it's the best editor. If you don't use Vim, you can. There is support for TextMate, Sublime Text 2, Redcar, which is an editor, Ruby editor written in GRuby. So it's very nice. And Redcar probably has the best integration so far of RubyMotion, because from the editor you can create projects. You can they even have an integration with the debugger that was released like 10 days ago. And you can also use Emacs if you like, if you have enough memory on your computer. And the RubyMotion, I'm joking, of course. Emacs is great. Yeah, I think right now with dual cores it's okay, right? So the RubyMine, so we are working with the JetBrains people to provide RubyMine support. So we are working with, to provide a RubyMotion support in RubyMine. So the next build of RubyMine will feature complete RubyMotion integration. And this is really awesome because these other editors provide autocompletion, more or less, of the APIs, but they don't provide smart autocompletion. So here I would like to show you a beta of RubyMine, only screenshots. So if you start typing UI window.alloc.init and you hit the, I think it's the escape key to provide the completion window, you can see that it provides meaningful information about the context. So it already put the cursor on the init with frame, which is what you really want to call here. You want to create a window with a frame. But this method is defined on UI view, which is actually a superclass of UI window. So we click enter, and then you need to provide the rectangle of the frame you're going to build. And for that, we start with the UI screen. We want the rectangle of the screen. We just type UI screen dot, and then it proposes main screen, which is also what you want. So you click, boom. And then it provides bounds for you, because it wants you to return the rectangle. And you click, and you're good. Oops. Anyway, so this is actually going to be released in a few weeks or so. So if you should check out the RubyMine blog if you like. But this is really, really great. I mean, this feels like magic. If you like IDEs, that's probably what you should use with RubyMotion. So the community. Oh, that was fast. Last time I looked, there are about 500 projects on GitHub related to RubyMotion. So most of them are samples. People write small samples and they just put it on GitHub. But there are also libraries. And the editor stuff that I showed before, of course not RubyMine, but the other editor support is also on GitHub. So there is a nice community around, and I would like to show you a few of the projects. And the first one is TCAP. And TCAP is an effort of providing a DSL to write UI. So they follow the CSS principle in the sense that you define the style in a style sheet object. For instance, you provide default styling for widgets like text fields, search bar, or buttons. And then you apply the style sheet to a specific view controller. And all the elements of that view controller, we actually use the style defined earlier. So you can really separate presentation for, I don't know, how is it? Style from presentation, whatever. So, like in CSS, in web development. So if you like that. Bubble wrap is a framework that has a lot of thin wrappers on top of very specific iOS methods. So everything that's more or less complicated, they tend to write a Ruby wrapper for it. And for instance, if you want to do an HTTP post using the iOS APIs, it is not easy because you need to create at least 2 or 3 objects. You need to provide an integration with the run loop. You need to provide a callback block. So it can be hard stuff. Here, you just use the bubble wrap HTTP post method. You provide the URL. Then you provide a block that will be called when the HTTP method is actually performed asynchronously. And this is much better than using the blah, 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 blah. And there is also a JSON wrapper if you want to parse or generate JSON, with just one line of code. So most projects, most RubyMotion projects use bubble wrap, I think. For motion, it's also great. It lets you write what you see on the right just using a giant Ruby hash. So if you have done a bit of iOS programming in Objective-C, you know that generating this kind of window, this kind of preference window is actually very complicated because it's a special UI table view with different cells, different sections. I mean, you know you're there for at least a few days of work, right? And here you can just create a giant hash and pass it to the method, and it will build all the UI. So there is no reason why you would want to do this programmatically. So that's for motion. Parse model is an integration for the parse.com service. And parse.com lets you, I think it lets you have some sort of key value table in the cloud or something like that. So you can actually send data to the cloud and get them later. So you can implement the backend of your iOS app very easily. So they provide the SDK, and this guy wrote a RubyMotion gem for it. So it looks a bit like Rails, I think. So you define a class, you define the fields, and then you can just create an instance of that class, set the fields, and then hit the save method. And once you hit the save method, the data will be written into the cloud, whatever, network. And finally, there is this project called Motion State Machine. So I have no idea what the snippet does. It's some sort of state machine. Different states. So what's interesting here is that it integrates with the UI notification. So you can create your state machine first with different states, transitions, and then you can hook it into the UI main loop, the UI kit main loop, so that when a notification comes in, it can start up the state machine into a specific transition. So you can more or less do asynchronous programming with it, I guess. And what's interesting is that the entire library is written on top of GCD, Grand Central Dispatch. It's a C-based library that Apple provides you to write concurrent code. And this is all based on that library. So all the transition you see, the proc, are going to be executed concurrently. And in RubyMotion, there is no giant interpreter lock that prevents two threads from running in parallel. So you can use all the cores of the machine or the phone, of course, if you use this library. Anyway, so I think I have time to actually do a demo. I have a bit of time, right? Okay, let's do a demo then. So let me go to TMP. Let's remove first that one. Okay, so I'm going to create a new application. Motion create hello. And it creates a hello directory. And as you can see here, we have a rec file, which is the project configuration, with a hub directory, which has just one file. The resource directory is the directory where the resource file should go, like images. And finally, there is a spec directory that contains the tests of the app. So I can go straight there and type break. and it's going to build a project. Let's remove that. What's happening here? Oh, it's trying to connect to the network. So let's just... Okay. Every time you run the build system, once a day, it will check if there is a software update. So, and here it starts a simulator, and oops, what's happening here? Okay, here we go. So my machine is very slow today. So the simulator starts, but there is nothing there. It's just a black window. And why exactly? So if we quit, and if we actually check the code, you can see that it's a basic class with just an empty method there. So there is no code there. So we can add the code. We can, for instance, create a alert view. And we can set the message to... and we can just show. And if I type break again, build, it starts the simulator. And since Xcode 4.5, I don't know why, but the simulator takes 2 seconds to start. It's very hard, and even on Objective-C. So, and yeah, so the dialog shows it works. But let me show you a more complicated sample. So if I go to my source directory, Ruby motion samples, and I'm going to show you the timer app. And the timer app is one of the samples we build, and it's basically a simple application that has a timer. So it has a label here, a button, and if we click, it increments the timer. If we stop, it stops the timer. And so first, one thing that's interesting here is that when we start rake, we start the simulator target, and we have some sort of REPL here, a shell. So I can type expressions here, and it's going to interpret these expressions inside the application that runs on the simulator. How do we do this actually? So we have a just-in-time compiler just for the REPL that's going to generate machine code for this specific instruction, and then transmit the machine code to the application. But using this REPL, you can actually access the entire object, the entire application from the command line. So I can use UI application dot, and you can see that I can use auto-completion here, shared application, and then I get the instance of the application that's actually running right now. One thing very interesting is the REPL is a bit magic. If you maintain the command key on the keyboard and then you move the mouse over the simulator, you can see that right now the views I'm hovering with are in red. And here on the REPL, you can see that the view changes. And this is going to be the self object of the session. So if I click here, which is the main view, boom, now I'm back in the REPL, and I started a new REPL session whose self-object is the UI view. And then I can, for instance, check the background color, which should be nil because there is no color. But I can assign a new color, for instance, UI color dot blue color, and it's blue. And so that might look simple and stupid, but it can be very handy when you actually debug an existing application. You can drag any view and start typing stuff and move the frames, and it can be very handy. So, and this kind of thing, as far as I know, you can do that in Objective-C. So that's the REPL. And now I'm going to show you the debugger. So if I exit, let me open the timer controller. So that's the code for the example. And yeah, here, for instance. Here I'm just going to remove a letter and then save the file. So instead of invalidate, it's invalidate without the ending E. So I can not rake, and then I will just use the debug1 variable so that it starts the debugger. And okay, so the application is here, and I can click start, it starts, and if I can stop, boom, it breaks, because an exception happened. And so here I'm in GDB, so I can type BT, which is the shortcut for backtrace, and it will print the entire backtrace. So you can see that we start with main, which is the main C function, then we start with the UI application main, and all the way through, oops, my code here, action tapped, time the controller, line 26. And here, something happened that we can see that we trigger a method missing exception. So you know, just by looking at the backtrace, you know what's going wrong here. And this is frame 7. So if I type frame 7, boom, no, I switched the frame to the 7th frame in the backtrace. So here I'm actually in the Ruby code, as you can see here. That's my piece of code in the file. And if I type hell, I can see the source code. And this is really, really great. And here, for instance, the self object in RubyMotion is actually passed as the first argument. So I can, for instance, type PRO self, and it will print, it will crash, because the object is no longer available, so it died. Anyways, so PRO is the equivalent for print Ruby object. And you can call it to print the value of a Ruby object inside, like local variables, and so forth. So, and then it crashed because an exception happened, so there was a garbage collection to self, and the object is no longer available. But anyways, that's the debugger. And it may not be very high level right now, it's very low level, and you need to know a bit about like stack traces and pointers and these kind of things. But we are going to build a higher level debugger in the future. And finally, I would like to show you the spec file, the specs. So the spec framework lets you trigger a set of specs for the application. If I type the regspec command, it's going to build the application again for a spec mode. And here it's building the library, so the beacon stuff and the layer. And now it simulates the application, and you can see that it does stuff. It starts and stops, and then it quits. Oh, and then it fails, no method error, of course, because I forgot to fix the bug in the application. If I actually, I can fix the bug now. So here, up, oops, no. Okay, can regspec again. It's gonna build just this file and run it again, and now it should pass. Boom. 0 failure, 0 error. Awesome. Voila. I think that should be all. I think I show you pretty much what I wanted. So let's go back to the slide. Okay. If you have any question, and thank you again. Thank you. So if you guys have any question, oh, by the way, the RubyMotion Twitter handler is @RubyMotion, so you can send questions there if you like also. Okay, yeah?
What kind of garbage collection is going on?
So in RubyMotion, we don't use so we actually use the same memory stuff that powers Objective-C. So we use return release cycles, return release counts, and then delayed garbage collection through the use of NS auto release pool objects. So it's basically doing the same as Objective-C does right now with the Arrrrcamp, which is an automatic return count system in Clang. So basically, it's not true garbage collection in the sense that there is no runtime logic to garbage objects. So it's more or less delayed garbage collection. So you allocate your objects, and then once it hits a specific auto release pool, and it's going to destroy the object. So that's what we do right now. But we are working on improving a little bit the story here, because we want to detect referred cycles, but we don't want to add a runtime cost there. So we want objects to be created as fast as they were. We don't want to allocate more memory. So it's actually very tricky. But we actually have 2 plans to solve this problem. So I'm pretty sure by the end of this year we have a story for. I don't want personally to introduce weak references in RubyMotion, because It's 2012, and there is no reason why programmers should care about weak references. Yeah.
Is there a plan to recreate some or the entire Ruby standard library within the Ruby motion? Like for instance, the JSON library, now bubble wrap has that. It would seem like it makes a lot of sense that that would be available within Ruby motion. You can just, instead of saying bubble wrap JSON, just JSON.
Yeah, probably. Yeah. The thing is that this is growing way too fast, the whole thing. So bubble wrap was already released and available before we even had the opportunity to write the standard library. So and but yeah, probably in the future there should be some library that ships with the Ruby motion for the basic stuff like I agree, JSON, HTTP stuff. Yes.
Except for eval, are there other limitations on metaprogramming? Can you do metaprogramming?
Yeah. So you can do everything except eval with a string and require. And also, so for performance reasons, I also remove some features of Ruby like proc binding, which is, I could talk about that for a few minutes, but it's actually a very bad thing in Ruby. It prevents compiler optimization. So, but normally, people are not going to use that for metaprogramming. They're probably going to use eval, create modules, create anonymous classes, and define method and so on. So, yeah, there shouldn't be any problem. Yes?
Do you need a license to get started?
Do you need what?
Do you need a license to get started with Ruby motion?
Yes. So it's a commercial product. So and the thing is that we, so you need to buy a license to use it. I'm trying here to build a startup in the organically. So I'm not looking for I'm not taking investments or these kind of things. I'm ready to thank you to create a startup. I think a company that and you if it was free, you need to take money elsewhere for the development and get sponsorships and these kind of things. And I think it's probably better to ask the users, so that the users can be the customers. The customers, not necessarily sponsors or. Yeah. Anyways, so it comes with 1 year of software update and support. Yeah. Yes.
How do you handle external dependencies in an app? Is there an equivalent of RubyGem?
Yeah. So you can. So RubyMotion lets you bundle third-party frameworks, C or Objective-C frameworks, and you can do this manually. So in the rec file, you can actually type vendor project, and then you pass the complete path of the Xcode project, or you can use CocoaPods. And CocoaPods is like, if you don't know it, it's like Ruby gems for Objective-C libraries. And so there is an integration with CocoaPods. And so you can just install a pod, like you would install a Ruby gem, and then just use it inside RubyMotion. And it works great. For instance, the Cocos2D game framework, which is a huge framework, you can just, in one line, bundle it in the RubyMotion project. More questions? Yeah?
I was wondering, you show some example, but most of the code that we could probably do in this kind of application is interacting with existing API. You said they are the same but for C, but that leads to code that may be Ruby, but doesn't feel so much like Ruby.
Yeah.
Do you have any plans to do something? I saw some of your ecosystem is one part of the response. Do you have another one? Do you intend to bundle or to warp some of the common libraries, something like that?
I think it's probably better designed to just ship a runtime that is as small as possible and to not bundle anything unnecessary, because there will be you can take anything you want, the dependencies. So you're right that it's based on the same APIs. So, but Ruby is a much more convenient language, even if you use the same APIs. You can most of the time you have, for instance, all the iterations, parsing text. So you have regular expressions in RubyMotion. I don't know, iterations. It is much better. So right now there is no plan to bundle a wrapper or library. So I think it's better to let people do that so that we can actually focus on fixing bugs in the runtime. More questions? Yes?
You said you could run across code libraries into Ruby Motion projects.
Yeah.
Go the other way around. Can you use Ruby Motion to write a static code?
Yep. So there is a reg static task in the project that regenerates a .a file, universal.a file. Then you can just drag this into the Xcode project. And then you need to add a few libraries also, but it's all explained in the blog post, I think. Last question, very last. Yeah. I'm afraid I didn't hear the question. Yeah? Yeah. So you would like the spec to run on the device?
No, if you're doing browser testing, you can like have a browser that is headless without the UI.
Oh, I see. So sadly, no, you can't, because you really need to have the simulator started, because you need to deal with the UI. Yeah, I'm afraid so. But we are actually working with a startup right now to provide a service to improve the testing story. So it's going to be a bit better. But yeah, so you really need a simulator, because you need the simulator framework to be loaded, and it's kind of complicated to set the right environment variables. And sometimes you just want to click on the window, right? So if you want to test just the backend of the application, you don't need a simulator, of course. But most of the time, you want to test also the UI, right? You want to verify that transitions are working, or buttons. You can click a button, it switches to a separate view. So. I see. So right now there is no support, but there is no reason why we couldn't run the backend test outside of the simulator. So, but that's actually the first time we hear about it. So we could do it, yeah. Okay. Well, thank you.